My name is Steve Coutoumanos. I am the co-founder and chief product officer of ByteTrail. We are a Plano-based company. We've been around for about a year now, and we're more or less been in stealth. We're emerging from stealth right now. Okay. My CTO, Brandon Gruters, is here with us as well. So what we're going to be talking about today is xIoT, digital atrophy. You can also replace xIoT with industrial IoT. We're just trying to cover all our bases there. So, quick question. If I say xIoT, digital atrophy, anybody have a definition for that? No one. Venture a guess?
Well, the remote devices out there are not being kept up. They're beginning to lose their power efficiency, effectiveness.
There you go. So that is very much spot on. So what we're going to do first is we're going to thanks, Gary, for rescuing me on that deal. All right, so let's unpack that a little bit. Okay, so first, where there's smoke, oh yeah, so 15 billion xIoT devices in chaos. So that means that 75% of 20 billion xIoT devices are not updated, they're not managed, they're not secure. Okay? But everything's fine. Okay? So there's a lot of evidence that goes into that 75% figure. One of which is from Microsoft. So Microsoft, with their OT deployments, they discovered that 75% of the OT devices had critical vulnerabilities. Okay, unpatched. So we've seen this movie before, right? So think back to the early 2000s. I think everybody in this room can. That's about that time there was the beginnings of automation for software updates, right? Initially it was there was a lot of user interaction, but later on, we end up with Patch Tuesday, right, from Microsoft. And then if we go to the early 2010s, there's the advent of the smartphone, and those become managed. We start getting updates for applications. Nowadays, I mean, I look at my ByteTrail branded iPhone, by the way. If y'all want one of those, just let us know. Applications are updated with impunity. Operating system, libraries, all of that stuff is very seamless and transparent. From time to time, you'll get a notification saying this is going to happen while you're asleep, and lo and behold, it's done. Pretty much opaque to the end user, right? So then we get to xIoT. Okay, not solved. Nothing. That's a little scary. I mean, you think about it. It's 2023, and this isn't happening. And it's not happening 75% of the time. But I would posit that 25% is a little iffy. I mean, there are some companies like Tesla and Google with their Nest products and such. Those are closed ecosystems. They're doing a good job with that. Okay, but really, even that 25% is suspect. All right. So the moment xIoT devices are released into the wild, digital atrophy begins. And it's literally like that. Good luck.
So what are examples of these devices? I happen to know IoT, but I'm curious to know what are the devices that are not getting updated? Are they router, their sensors, or,
No, we're talking about all the universe, and that's why we use xIoT. Okay, in a little bit we'll talk about device classes and devices, stuff like that. But we're talking about, if you look across the board, from the smartest IoT device down to the dumbest, that 75% of those have no care and feeding whatsoever. Cool. Makes sense.
no, when you get a device, that'll have a better idea.
Say again.
When you get to device classes, I'll have a better idea.
Okay. All right. So yes, these are released in the wild, and they get implemented in the field, and then that's kind of the end of that story for the most part. All right. So what are the moving parts? And this is going to go back to your question. Okay, so we start with care and feeding, but we need to think of it by device class. And if you look at it from basically from top to bottom here, you've got the most intelligent devices, if you will, down to the dumbest devices. Okay. So at the top, we have things like gateways, industrial PCs. You have hardened, ruggedized, like Raspberry Pis that are deployed for industrial uses and so on. Come, down to the next level is these are microprocessor-based systems. Yes, they have things like OS and applications, but normally they're more or less running a point application for something very specific instead of something general like a gateway. Moving down further, we have microcontroller-based devices. So these are firmware-based devices running things like RTOS, what have you. Again, functioning in a very point function, if you will. And then you have constrained devices, smart sensors and such. Those don't have a lot of capabilities. Okay. So the main notion here is that the care and feeding from this device moving down to these devices is there's a lot more here and less here and less here and less here as we move down the stack. Okay. All right. Care and feeding by device. So now that we understand device classes, the main takeaway here is this needs to be continuous. Okay. So continuous is updates, scanning, monitoring. Okay. That has to be done with impunity. Right. Now, again, depending on the sophistication of the device, we want to be able to update things like operating systems, firmware, applications, middleware, you name it. And also containers, by the way, that should be showing up there. Micro containers, if you guys are familiar with those, like Moby and such. Then we also want to be able to, depending on the device, be able to rotate certificates. More and more, you have inference libraries that are being used by AI at the edge. Okay, that's a very continual process for that one in particular. Then, just from a holistic management standpoint, we want to be able to monitor all of this or observe all of this. In addition to having scanning for vulnerabilities for the software that exists in a particular ecosystem, and then also configuration. And there's also such a thing as configuration scanning, where you want to validate the device is still configured in a proper way, perhaps for compliance purposes. Why should I care? That's a big question, right? And especially with in this domain, I was going to say it seems as though the industry is thinking this way. No, it's actually the way the industry thinks in IoT. It's all about data ops, okay? And yeah, that's the starting point for everything. But it seems like the hyper focus that has occurred in that area has created a blind side on the device operations. So this is notional, okay? And really what this should look like is one of them should look like a hockey stick and the other one should look like a inverted hockey stick. And the number of devices has been growing exponentially. We started off with, tens of millions of PCs, and it's grown smartphones and, tablets, edge computing, xIoT devices, all these other future devices and technologies, okay? So, right now we're seeing at 20 billion plus, right? Just for the xIoT stuff. Then you include all those other devices, very much hockey stick. Conversely, you have the ability to manage those devices. Our ability to manage PCs is pretty damn good in the scheme of things now, especially with the adoption of zero trust. And then you look at smartphones, tablets. I mean, especially the Apple ecosystem has done a fabulous job there. Edge computing, depending on the application, sometimes good, sometimes bad, box of chocolates kind of thing, And then you look at xIoT, and it's absolutely abysmal. It is terrible. There's one thing that you guys take away from this entire talk is where we are right now is not sustainable. It's not. All right. Where it matters. Well, operations, security, regulation, compliance. But let's talk about operations first. Look at the impact of reliability, performance, productivity. Okay. Now, here's an interesting use case. So, why is this like a hair on fire issue in operations? Well, there's many examples, but here's a good one where a study was conducted. 96% of the large manufacturing orgs, they had certificate outages, which meant the certificates expired because they were not properly rotated. Again, going back to the whole care and feeding theme here. And each one of those instances cost the companies $2.25 million each. That's just for certificates on an IoT device. Okay.
So what's the impact on revenue for that particular organization when you have these kind of numbers showing up? It's 2.2 billion. That means it's probably a significant percentage that's hitting the top line, right? So it's a big business.
And you also have to think there's a reputation impact because if they're shut down, then there's delay going to the customer, yada, yada, yada. I don't think that's wrapped up in the 2.25 million. Yes.
I'm raising my hand just like it. I just
Feel free to speak up.
all right.
Yeah.
All right. Yeah. So when you talk about industrial internet, are you talking about protocols like Wi-Fi, DOE, or are you talking about something ultra low power like, like a field or a walk or something? Or are you including both?
So where we're at, in this part of the discussion is I'm really talking about all of them. Okay. So we're talking about your ubiquitous xIoT device. It's running its protocol or one or more protocols. It has, it's a good question because really what you're poking at is you're poking at how heterogeneous this space is, right?
I want to talk to you all afterwards because, you know, to comment you made earlier about the Google ecosystem, that there is new standard out for any given device, connect to Google, Apple, Samsung. In other words, there's network standards that are very reasonable that allow a device to connect to multiple ecosystems now, which might be of interest. So I'll talk to you guys afterwards.
Sounds good. Have you heard of that? Okay.
I said
All right.
the Matter protocol.
Yes.
Have you heard of that? Okay.
Okay. Security. Data breaches, ransomware, network compromises, you know, think Colonial Pipeline, you know, there's many examples here, but we didn't want to put a logo here. So let's just say that this retailer has red in their logo. So, you know, large retailer, and some of you may have been affected. I was one of them. Anybody in the room affected by the Target breach? I was. Our president was as well. So that exposed the breach was mounted via an industrial IoT device. That's where they built the beachhead, and then they expanded from there. Okay. Security, you're only as good as your weakest link. Okay. Regulation compliance, of course, we think health, safety, environmental, critical infrastructure. This stat right here, this sounds a little bit like a repeat of the Microsoft one, but it's really not, because in this case, 68% of xIoT devices were found to have high risk critical CVE scores. CVE is common critical vulnerability enumeration, right? And if you guys are not familiar with that, that goes all the way up to National Vulnerability Database. So what's kind of neat here is that these are companies that are probably doing a good job because they went so far as to create a software bill of materials. Okay. Talk about that here again in a second. How many people are familiar with software bill of materials? Anybody? Okay, cool. So we got just a sneak peek. There's software bill of materials. There's HBOM, hardware bill of materials. There's, in our case, there's VexBOM, which is vulnerability bill of materials. And then you can wrap all of that together, at least that's what we're doing, is a operational bill of materials. Anyway, back to the point here is that even the companies that were doing good enough to generate a software bill of materials, what they're doing, 68% of them had critical vulnerabilities. These are probably forward-thinking companies. So,
to reiterate on that, not only the security but the vulnerabilities, most of the major hotel chains that have electronic locks, the only way they can update their security after they have a vulnerability, it's already happened once, is 1 million locks had to be created for new security. The only way they can do it is a physical touch for every lock across the US.
that's right.
Every room. Same thing holds true with several million electric meters have to be taken out. Water meters, this is a very, very large unknown world that we're talking about here that is very real, that the 3 to 4 to 5 years worth of deployments of solutions for the next generation of things, all of that had been left out. Money saving solutions, and now we're going to be. So I just want to reiterate, those are really big numbers.
Yes, and the only remediation for the 75% plus is exactly what Scott was talking about here, which is, we call SneakerNet, got a USB stick, and I got to go touch all of these. In fact, ByteTrail's first customer, they do water purification, and it's highly distributed across the United States. They go into emergency situations, and then there's oil and gas applications as well. They have to first fly an IT person out to those remote sites with the USB stick. They have to jump in a car because those are located in God knows where. Okay. And then as a cake topper, if say it's an oil and gas application, it's there's hazardous chemicals and hazardous materials, so they have to be certified. Okay, so I'm thinking this is like one of the most expensive IT guys on the planet, or women on the planet, that you have to send out for a couple of days before you get them back just to do this. And also, I can tell you, with that particular customer, they're spending $250,000 annual for about 225 rigs just to do that, just to put it in perspective. Okay. All right. So what is the solution? So spoiler alert, we don't need any more tools. We don't. And in fact, I say the poor IT people, and I've had a love-hate relationship over the years, just sidebar, not for everybody. But anyway, so look, they have to bring in the tool du jour, they have to put it in their tool chain, they have to have a staff of people to not only implement that, but to manage it over time. Okay? The industry does not need that anymore. What they need, Brandon said it earlier, I'm not going to say exactly what you said, but he said, everyone needs epic solutions. That's what everybody needs. That's what he said. So. All right. We have to keep in mind that all solutions are not created equal. And I get this. This is very academic. I get it. But it's, when we talk about solutions, we're talking about people, processes, and tools, right? People, who should be involved, okay? Process, how it should be done, okay? So the tools should enable the people, and then should support the process, right? But it's been bastardized, okay? It's more like we're going to use people to close the gaps on the terrible tools that we have and the terrible processes that we have, okay? They're manually driven. Someone has an Excel spreadsheet, managing this thing. And then you have the, basically supporting the process. If the process is all manual, then I'm not sure we can really call that a process, because things like this require automation. Humans are absolutely terrible at this. This is why we have machines. This is why we have automation. Okay. So good segue. A solution is needed that is continuous and automated. And we're talking about holistically, device operations, security operations, and then wrapping that as totally managed, soup to nuts. So to the end user, just like my iPhone, it just works. All right. Enter ByteTrail. So Brandon and Brenda and I get faced with a question all the time. How, with all of the disparity of the devices, tons of applications, all the OS, many different protocols, how are you going to do that? And we're not trying to be pithy here, but that's why we wanted to point out any sufficiently advanced technology is indistinguishable from magic, and my favorite authors, Arthur C. Clarke. So it's not as hard as you think under the covers, and we spent the last year building the foundation to make this real. And we have 1.5 customers now where it is real. So I've got to stay at a very high level here. So ByteTrail under the hood. We go from cloud to ground, meaning cloud, edge, down to the one-to-many devices, okay? And all the components and services that are on that device. But you'll see on edge, I've got edge in capital letters there. And the reason for that is we are edge driven, and we have to be, okay? The reason is, everything is moving to the edge. There's more AI being driven to the edge because it's faster, responsive, more cost effective. Cost of computing is going down, cost of networking and going to the hyper clouds and just pumping all the data up there is either level or going up. All right. So just a quick question. How many people in the room are familiar with Rust as a program? Excuse me, programming language. One? Okay. So, sorry, my allergies are absolutely killing me. Brandon changed his middle name to Rust, just so everybody knows. Okay, so the notion is, those of you who are familiar with C, think about a version of C that's more secure, more compact, much more efficient, okay? And the vast majority of our stack is built with Rust, okay? So this is part of the evidence where we say, okay, there's apparently some magic going on here. It's not really magic, but it's tool selection for us. It's design, and it's things that we've learned over the last 25, 30 years, okay? So ByteTrail from cloud to ground, okay, how does this work? So you can think of ByteTrail, the ecosystem, more or less as a graph. Those of you who have ever worked with graph databases and such, okay? So how we sort of split this out is we have the notion of orgs and sites, okay? Orgs are, think of an enterprise, and there might be a main org, and then they might have a bunch of sub orgs, okay? And then those orgs then have a site. It could be local or it could be remote sites. All of that needs to be part of that graph. And then the underpinnings of that, after we get past the edge services and the agents that are running out on the edge, is what we were talking about earlier with the operations bill of materials. Because in this case, the devil is in the details, okay? You have to have a detailed inventory of exactly all of the components and services and dependencies and transitive dependencies, okay? And in order to make this work soup to nuts. When I say make this work, I mean to be able to be effective, okay? No one is doing that in the industry except for us. No one. So here's just a quick visual description of ByteTrail update workflow at scale. So if you can imagine those services that we talked about moving across cloud, edge, what we're able to do is, through the use of the operational bill of materials and the services that we've discussed, is we more or less move backwards, okay? We identify all of the devices that are impacted by something, okay? Let's just say there was a critical vulnerability that was discovered and it's affecting a certain class of devices. We'll go identify all of those all the devices that belong to that class, and then we will work to remediate that. Then as we go backwards, we determine what the edge processes are that feed into the devices. Then moving back, we know the sites that are affected that lead back to the devices. And then of course, going back to the org. So maybe that makes a little sense. We can have Brandon talk to that a little bit more if you guys would like. So tying a bow on this. The ByteTrail automated end-to-end solution. This 9 box, although maybe it looks like an eye chart. These are all of the things that are needed in order to do, what we've been talking about here, okay? In particular, on the left-hand side, I think those are the main takeaways. So updates for all the devices all the time. It doesn't say some of the time, it doesn't say, let me guess at it, let me be reactive to it. It says all the time, I know what needs to be done, okay? And just as importantly, what goes with that is the workflow and orchestration. You can't, you were having a conversation earlier talking about healthcare applications. So you were to push an update and this, some device and somebody's having surgery and it shuts that thing down. That can't happen. Okay, so you have to have those tight systems and those capabilities in place to make that first box happen. Secondly, frees IT and enables OT. Man, I think this warms the heart of many of us in the IoT space. Question.
So you're addressing the healthcare market as well, right?
The short answer is not really.
Okay, so that's.
And let me be a little more precise with that, because we could, but all of the regulation, everything else, there's a lot more low-hanging fruit in other areas, particularly energy, critical infrastructure, They're also in manufacturing and also in enterprise, as well.
Because some of the orthopedic components and instrumentation are moving towards devices being used remotely for surgery. For instance, Anderson down in Houston, I know the Quantrify has prostate removed with the doctor operating robotic arms.
Been there, done that.
stuff
By the way.
like that, right?
Maybe that's TMI for everybody, but yeah. Okay.
So those are also IoT devices.
Yep.
That's why I asked the question.
Absolutely. Question.
I didn't get your name, I know I mentioned others. There is a way to get into, we would call it the wellness market, assisted living, aging in place. I totally get what you're saying about, if it's qualified as a medical device, you pretty much have to be just in that business.
Yeah.
But if you're talking about things like assisted living, they're kind of converging because, all of us are probably going to be in this situation at some point, probably closer than a lot of you. But, for an aging in place kind of environment, you can begin to kind of work into that market, with temperature, smart home stuff in a different setting. But once you get that backbone in place, then once you go through the certification hurdles for medical
Sure.
devices, then you're going to have a common backplane to plug that into, right? So there is a way to kind of get into that market without, jumping all the way into like medical device market.
There's a UK company that has already just started doing that.
Assisted living or,
Yeah,
or
in fact, they have an IoT device that sits in homes, manage a whole lot of things, including temperature, all that kind of stuff.
That's a good point. It's almost like you got a flanking maneuver to get into the,
You can lay the groundwork
Yeah.
for it, and then, when you get enough scale, if you want to enter that market, it's, I've done healthcare before, it's very difficult. You can get pretty close to it. Taking care of aging people is a pretty good business to be in, but it doesn't have to be a medical use case necessarily. So
Yeah.
it's still a big opportunity.
that,
And I'm saying that as an aging person myself.
well, I believe you as an aging
I
person.
understand.
So. Okay. And then proactive security. Notice we didn't say reactive security because that is how it is done with a small exception. Okay. And, we look at this, much like some of the use cases you guys have been pointing out is, look, we're here to make a buck. We're here for our company. We're here for our employees. But something like this is good for the greater humanity. Okay, it's so needed, and that's why we're so passionate about it. So I think with that, oh wait, one more point that I might make is that it's interesting that just as we look at this. In all of the benefits is we recently we had to do an exercise of, okay, what do we have in our sales pipeline, right now? So that means we've either been referred, we're actively talking to someone, or we're in pilot. Okay. So with that, we are able to make all of the numbers that we are giving to both our investors and prospective investors. So what I'm saying is just our existing pipeline to show you the need is creating enough revenue for us to make our plan without, look, we're not going to close 100% of those, right? But just saying with those customers which most of them are medium, large to extra large. Okay. We did it that way on purpose. We don't want to be industry experts in healthcare and microgrid technology and stuff like that. We can't. But we are selling to the companies that are selling to the one-to-many other companies that they have in their portfolio. Okay. So it's very leveraged the way that we're approaching this. I say leveraged, I just mean with that one customer, they have access to hundreds of customers. Okay. And so that provides us with the exponential growth, gets this out in the marketplace where it needs to be. And life is better for all of us if this is out there. So that's my story. I'm sticking to it. I think my voice is about gone. So questions?
Go to slide 1 for me, go all the way back to slide 1.
Scott, you are so high maintenance. I will do this just for you. Okay. Slide 1?
Digital back up to that right there. The question of hearing that for the first time and going through the process of how bad it is, we need to be aware of that because this is a global thing on the amount of things that aren't being addressed because of lack of security, lack of technology and solutions like this. We have another client, a great example, rolling out a brand new product. They're a Fortune 500 company. They're putting in electronic door locks to storage, self-storage units across the globe. Millions and millions and millions of doors. We were fortunate to be one of the first client. All that being said, to the point of this is a brand new technology and the way they can update it when they had a breach is to fly out and plug in and update the firmware because they had no visibility on what was happening. This is brand new in the last 9 days, releasing a brand new product. And they're going to affect potentially 40, 50 million doors.
Have you introduced them to Steve yet?
We already know him, so it's fair that, yes,
Yes. And we're also working with one of the, hopefully on the path to working with one of the largest telecommunications provider on earth. I don't know. You guys can fill in blank who that might be. But things like 5G gateways and such, if you can imagine, if we get, if we're seated, if you will, on a 5G gateway, that enables all of the downstream devices. There are ways, let's put it this way, beyond just monitoring and observability, but then we have the opportunity at that point then to be able to manage those devices with less friction, okay, for the end user. Okay. So anyway, I think there are some very large companies who acutely understand this. I think that most large companies have difficulty with innovation, specifically in software. My CTO he's got a t-shirt that says that. Yeah. So that's why it's important to, for us to really put this mission out there, because everybody says, nope, that's possible. You can't be doing all that. You can demonstrate it right now. Okay. We're doing it right now. We're not doing OS level for, firmware updates. We're very focused on application, configuration, monitoring, to give you the observability just like Scott's pointing out, and doing that with impunity. Okay,
Agent-based.
it is agent or agentless.
So you are.
Depends on the application.
Yes. Yeah, we can talk about the abstractions that make that possible. if we want to do that.
Yes.
So to do agentless, are you inline or offline?
Not, no, there's no passive on that. No. So what we can, in most cases, how the agentless would work is, I would say, you know, if you look at the most common RTOSs, there are LWMTM.
Yeah. we can
MTM
use that
is-
as a concrete
is-
example.
Yeah, it is an example, but, and maybe you should talk to this, but just to wrap up my thought there is you can leverage those things that are in place. Okay. And a lot of times they are in place. Now, they don't give you necessarily the deeper, and wider, feature function capabilities, right?
It's usually pretty limited.
LWM10,
Yeah,
Yeah.
it can be. So if
Yeah.
you think,
go ahead.
there was a good question about protocol earlier, and it kind of, it's one of the things that Steve and the product team did early on was help create the different strata of device classes. And within that strata, one of those is agentless for devices like LWM10. Now, LWM10 has a management protocol built in. And most of those devices have the capability. You're not going to get an agent on this device.
Yeah.
Some manufacturers may want to work with you from an OEM relationship standpoint to get agent code on there, but in a lot of cases, they don't want to, and they shouldn't have to. For those cases, we build the abstraction in at the edge. So Steve talked a lot about our edge capabilities. One of the reasons we're so edge focused is that our abstraction layer at the edge has pluggable device shadows, which we also update with our own software stack. That's another thing.
Can you define what?
I can, but it's going to be a long definition, so cut me off when I go too deep. But for us, a pluggable device shadow is basically an abstraction that makes that device appear as if our agent is running. That's the simplest way to describe it. So for all these agentless devices or devices that maybe have a proprietary protocol that has somebody else's agent on it, but they still want us to manage, the device shadow acts as a simple abstraction that makes it appear to our system and our ecosystem that Steve was describing as if there's a ByteTrail agent on that device. So with those abstractions at the edge, we can put as many out there as the edge can manage. So if you have 10 different device classes, there might be 10 different shadows out there running for, you know, LWM10 proprietary protocol, maybe, you know, something where it's some other protocol we haven't discovered yet or haven't seen in the field.
And then there's, you know, the,
translation layer. Basically, that's the
Yeah.
simplest way.
and then there's, you know, for some of the dumber devices, perhaps the only thing you can do is configuration and monitoring. Okay. And so through the use of the shadows, that's
And a lot of xIoT, particularly as you start getting into microprocessor-based gateway devices, it's much easier, obviously, to get an agent out there running, and that is a richer management experience. And so you do, in those cases, want that out.
Are you following a particular protocol or standard for your agents?
We are
There's a few
following,
out there. That's why
we're
I'm
following many in terms of communications protocols. There was a question about protocol earlier. One of the abstractions we built into our agent was communications protocol abstraction. And there's a lot of really good reasons to do that. Some of those are business rule based. Some of them are technology based. Our first customer that Steve was talking about, they cannot communicate out to these devices in the field except for anything except for a fairly narrow MQTT channel. Yep. We can support that. Some people can only support an OPC UA channel. Some people might support a higher bandwidth socket-based channel. We can do that. So we also abstract the protocols in the agent, in the shadows, at the edge. Steve talked a lot about foundational work. A lot of that foundational work was exactly this. What abstractions do we have to build in so that we can actually solve for this very diverse ecosystem?
Have you experienced it where you had one customer that had all four of those at the same time?
I will say yes, but
don't think I can name the second or third one.
Point being is you have to be there or you get.
Oh, yes,
Yes,
yes. And actually it's more than,
it's more than four. We're going
Yes.
through a pilot discovery process with this customer now, and we're going in the lab with them on, I think, 3 different classes of devices that are in 2 different strata.
So then back to the question then is that a necessity? Because there's other things that could possibly be close, but they can't support all of those protocols. Is that a necessity on where you are on building the fundamentals of the technology so that it can?
We're building those out now so that the shadows that I was describing earlier become habitable. We don't want our engineering team building shadows. We want to build this ecosystem so that if the customer comes along and says, I just have this one proprietary communication protocol. You can't put an agent on it, but can you talk to it? Because if you can talk to it, I can do it. We want to be able to farm that out. To be able to farm that out, you have to build all the foundation in and effectively get, don't like calling it an SDK, it's not really an SDK.
I do. It irritates, Brandon, but that's what I call it. It's an SDK that you can hand over to a third-party company. It's
Yeah.
easy.
It's still gotta be the data mapping at some point.
Yeah, and that's where all the bill of materials come in. Okay, so I would say even as early as 5 years ago, some of what we're doing is much, much more difficult because some of the standards that exist today did not exist then, like Cyclone DX. Cyclone DX is a very robust bill of materials standard that's being adopted all over the industry. It's the one that we use. There's another one called SPDX. It's a little bit heavier weight, not quite as flexible. Between those two, they have bill of materials standards that cover the vast majority of the industry. And more software companies are starting to adopt those. And one of the reasons they're starting to adopt those is that there's an executive order out that says if you want to play in government space, you have to have a bill of materials for your system.
That's Executive Order 14028. And
That was from a few years ago, right?
that was spawned in mid-2021. And what's interesting is it has expanded significantly to the point where right now, by the way, NIST has been leaning into this big time. And they're the primary agency that's been adding to it. But where we are right now is if you are a government contractor, okay, and you are working directly with critical infrastructure, there's no teeth to it yet. It's going to happen next year. It's happening in 2024. It basically says you must keep a detailed software bill of materials for everything that you're implementing. And by the way, that applies to the prime, that applies to the sub, all the way down. So basically, look, if you're a prime and your subs are behaving poorly, you're going to fire or, get rid of them and replace them with someone else. As the prime,
The price can't change, correct?
sure. But so then the new prime needs to make sure that they have everything squared away here. You have to demonstrate, you don't have to. At any point, the government can say, give me all the software bill of materials. We need to do a full compliance audit on that. You have to have that ready in order to meet that. Okay. Next year there will be teeth to it.
One part of our system, or I should maybe dump it as a lot because it's a pretty big part of the system, is our bill of materials management. And so as we update the systems, we are actively creating new bill of materials that completely represent the current state of that system. So that's done on the fly. It's done autonomously as a part of the software update solution.
Everything version.
Yeah, everything is version. One of the things that we'll do, for example, our first customer, maybe not the best example, but across all of our customer base that are running our agent. When we update our agent today, we're already using our system to push our agent out to these devices. So across multiple customers, we can know all device classes that are impacted by an agent update. For us, we can create new bill of materials for those devices, new software bill of materials, and new, what Steve was describing as an operational bill of material, which describes the piece of hardware the OS that's running on it, and then all the relevant software that's running on it. So we're updating those as we update the software.
And that was the big differentiator between you and say SolarWinds or some other companies that are doing.
Yeah, one of the reasons
Yeah.
that that executive order came out was because of the SolarWinds. Yeah. And so that's a really good point. What you're calling out is what's called a software supply chain attack. And it's where the attacker gets up early in the software supply chain so that as that software is distributed to other vendors, they replicate the attack across them.
But the audit is only for government projects.
Right now.
Yeah, because if it's a private sector enterprise, I mean, it doesn't matter.
So, and there's, by the way,
I would say it doesn't matter.
there's a sort of, interestingly, Executive Order 14028 was written for consumer. Okay. And that's where NIST said, whoa. Yeah, kind of this critical. Okay, let's add to this. This is kind of like the kernel of what we're doing. And now we're going to sort of expand on that. So yeah, it's not nearly as tight, right? But it's still there. Yeah.
And there's other standards that have started like this. I'm sure some of you are familiar with things like SOC 2, SOC 3, ISO 27001. All those standards started in one area. And now when you go to Amazon, they have to publish their SOC 2 and publish their ISO 27001.
So you would have a big play with all these, all for autonomous vehicles, electric vehicles.
So
That's a whole different ballgame.
yeah,
And they're vertically integrated. So if you think of a Tesla, they're vertically integrated. And there are very narrow segments of the market that have very, very tight vertical integration. From a business standpoint, you don't want to try to get in there and displace those vertically integrated solutions. So
You
That's right.
To the federal standards, or you actually automate that you actually have the workflow that handles the software supply chain.
we think of us as, since you phrased it that way, think of us as a software supply chain.
Yeah. Okay.
With an outro.
Yeah.
That's the big thing, is that.
Andrew had a question a while ago. Andrew?
Well, I was just gonna ask, so why would a company go to you as opposed to saying, well, we need to change our business practices and do this internally?
Cost.
So you're cheap.
Time to market cost and expertise. Some of the most expensive software engineers and IT people you can find today are security focused. What Steve was calling out earlier is true. The cost of getting those engineers, particularly in a tight job market, is very high. Finding an automated solution like ours, we're managing that for you, where we can leverage our expertise across multiple organizations that do it themselves.
And that goes back to the people, process, tools, analysis. Look, you can do it if you have enough, well, include time, people, process, and tools. Yeah, you could stitch all of this together yourself. Tesla has, right? But that's closed. So it's, are some going to wake up and do it themselves? Absolutely. Okay. But we demonstrated that the universe is so big here that there's room for those companies waking up. And we hope they do. Maybe as part of this, we're getting out there in the marketplace, those companies need to wake up. Okay, need to make changes. Plenty of efficiency here.
I'm just curious, why did you guys pick this to be the way you want to go?
You're better at the backstory. Yeah. It's a good question.
When we first started ByteTrail, we were actually doing something else in the IoT space. We were doing high-speed, high-performance interior space mapping. Basically, think of autonomous drones flying around indoor spaces. The safety and security concerns around that are extraordinarily high because you can't be bumping drones into people. As we were doing that, though, Steve and I came from a very long security background in enterprise security software, and one of the things these systems had to be absolutely secure, up to date all the time. They were, even though they were on the lower tier, they were very smart devices, had a lot of software on them, had to be kept up to date. We could not find anyone in the market who was doing all of that. That could update certs, that could update config, that could update software, that could update firmware. It just didn't exist, and it still doesn't exist. Where somebody's looking at doing that autonomously and automatically. And when you're looking at this problem at scale, unless you can do it autonomously and automatically, you can rely on an advisor. Think of our system as a trusted advisor, where we can say, this is the update we're going to perform. Are you okay with it? Where you could say, we give you the opportunity to say, oh, no, don't do that. That's a critical system. I don't want you touching it. But the vast majority of the time, you want to just be able to get those updates out because they need to be updated. Your systems have to be kept up to date. These are security patches. These are potentially efficiency patches. There's configuration changes you might need to make. Let the system deal with that for you. Don't send a guy out with a USB stick to update config into the trailer in the middle of nowhere.
Yeah, and also from a very pragmatic sense, our entire careers, his and mine, was built on back-end systems. That's where our expertise is. We're not front end. We're not robotics. So that was the other part of the transition, if you will. It felt really sexy, at the time. But then the practical realities of it is like, man, this is a big important problem. The more we dug into it, it's like the honest to God, we said someone has to be doing this. This has to be solved. And then people who we trust in the technology space said, oh, it's being done. Go find it. If you find it, I'm buying you as many beers as you can. Okay. So that was part of the journey.
And then if your question's more about the specific technology stack, longer answer, but we did spend a lot of time at the very beginning trying to figure out what's the scope of the problem. And one of the things that you'll hear me say, if you talk to me a lot, you'll get really bored by this, is I say we have to build for scale on that scale. This is a scale problem. There's so many different kinds of devices out there. There's so many different kinds of operating systems. There's so many different kinds of applications. We had to start by building a system that could scale because we cannot build it at scale. We have to build for that problem. That's what.